Welcome to AT&T ThreatTraq for December 3rd, 2013. This program provides network security highlights and discussion as well as countermeasures for cyber threats. I'm joined today by John Hogoboom, Jim Clausing, and Joe Bentfield, and I'm Brian Rexroad. And today what we'll do is go to what I consider to be, I guess, an obvious step, and Jim, maybe you can tell us a little about it.
Thanks, Brian. Last Wednesday, the day before Thanksgiving, FireEye released or posted a blog post about a zero-day privilege escalation vulnerability in Windows XP. And later the same day, Microsoft published a security advisory. But basically, the issue is with a certain system library that allows a user to gain kernel privileges. But the big thing that this brought to mind was, Windows XP is over a decade old, and Microsoft has extended support on it a couple of times, but they're ending support in April of 2014 for good. They're not going to provide any more patches after that date. So the big thing that this blog post and the security advisory brought to mind for me is it really is time, if you haven't already, to move off of XP. It's beyond time. Windows 7 has even been out for quite a while already. Windows 8 has been out for over a year. Windows 8.1 is out. So if you're using Windows, it is really time to get off of XP. And Server 2003 is also affected by this zero-day, so it's probably time to get off of Server 2003 as well.
So, I'm kind of curious. Do you have any thoughts on why it's taking so long to get off of XP as opposed to, I don't think there's been really a necessity to extend support. In the past, I remember, NT kind of went away fairly quickly. So what is it about XP that's making it hard to get rid of?
I think it's that folks got comfortable with it. It worked. It did the job that they needed it to do. The subsequent OSs, Vista, was problematic when it rolled out. A lot of people skipped it and went to 7. The newer OSs required more resources. I think it's just that a lot of people got comfortable with it. It's running on hardware that has been reliable for a long time, although I imagine that even the hardware would be starting to wear out now. I'm not sure exactly. I mean, I understand there were issues with Vista, and so people were slow to do that, but 7 was a lot more stable, and a lot of people have moved to it. There just seems to be this pocket of XP that's still out there.
Right. It seems like the applications that, so long as you're not, there isn't really that compelling force. As I think there were some other things that were kind of pushing things forward. NT was a little cumbersome in some ways, and perhaps there was more motivation to move on. So I think this is, clearly a case where it's time to move on here. And like you said, it takes a little bit of it takes a little bit of effort to do it, and folks should be trying to get that on their agenda. Absolutely.
Yeah, with them ending support, though, no more security patches after April. It really is time to get off.
Okay. Now we have a couple of topics here to discuss related to embedded devices, and I think the first one is a good news story here. That John, what can you tell us?
Oh yeah, thanks, Brian. So actually, Jim covered this previously, that D-Link, there was a vulnerability announced where there's an administration authentication bypass vulnerability. If you set the user agent in whatever you're using to be set to this specific string, XML set underbar root K, blah, 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 which actually is just backwards, and it reads edit by 04882 Joel backdoor. if your user agent is set to that, it will actually bypass the administration, authentication and let you work with the router in an administrative way. So the only way somebody remotely would have access to this is if the remote management was enabled on the person's router. That's not a default setting, though, but some people do have it turned on because maybe you have a small business or something and your router is administered by maybe some other small business provider, and they've opened that up for some reason. So it's one of those things that if you have a D-Link, specifically these specific versions here are the ones that are affected. If you have a D-Link router of this model or version type, you'd want to go to the D-Link website and get the updated firmware. Also, they made mention that there's some, I guess, maybe OEM or third-party devices that use the same firmware by Planex and Alpha Networks that also may be vulnerable to this. So if you have one of those, you might want to check to make sure whether or not you're vulnerable to this vulnerability. Again, only if you have remote management enabled are you really allowing somebody from the outside to leverage this type of vulnerability. But it is one that you'd want to take care of anyway. And we have the link to the actual D-Link advisory here that also has links to the firmware for each version that you might need to install.
All right, very good. And the sort of the special case here is that this was, unlike most vulnerabilities, which are errors in the implementation, this was a case where, somebody went ahead and put a backdoor in there intentionally, and I assume that was an unauthorized or, something that was stuck into the code, something that obviously, presumably is the distinction between open source versus the sort of the closed source solution. That is, an open source solution presumably would have had public review and caught something like this earlier. But nevertheless, it's good that it was caught and it's being corrected.
Right, and it's not clear to me in the articles that I've read if this was how this particular backdoor got in there. If it was by design, by the manufacturer, or not. They don't really address it. They just, mention that it's not there anymore. But it is a little suspicious.
Yeah, sometimes, and I can't really speak for this particular case, but, sometimes things like that are put in for testing purposes and tended to be taken out, and, perhaps it was an error that occurred that is, was in there for some particular, legitimate reason, just neglected to get taken out. It's sort of a configuration management issue. It's difficult to say. I don't think, like you said, I hadn't seen anything where they had suggested what the reason was, but nevertheless, like I said, it's a situation where it's being corrected. That's a good thing.
Yep.
Okay, so I guess still on the topic of embedded devices here, Joe, thanks for joining us today, and I guess there is always the possibility of embedded devices being compromised, and this one seems to take a little bit of a new twist compared to ones that I've seen before. What can you tell us?
Sure, and basically the story here is Symantec had doing some research and posted a blog back on the 27th of November regarding a vulnerability that had been identified in PHP CGI and patched back in May of 2012. What Symantec has found is a proof of concept that has been leveraged starting almost back in October. I think it's referred to as linux.darlaws. And it essentially does wormy kind of things, right? Generating an IP address, the research says randomly, but it's going after a specific path and leveraging well-known IDs and passwords using HTTP to exploit the vulnerability. So, kind of typical in the sense of, how worms are constructed, but leveraging this exploit and the way it's put together appears to be somewhat effective where you're vulnerable to those things. And it's kind of interesting at a, Linux level, if you will. So not too sure about how much is in the wild yet. But in many ways, it's a reminder to do good security things like disabling features you don't need, not running with well-known IDs and passwords, certainly change those things up, get the strong passwords. And then, of course, the HTTP path, block that traffic where it shouldn't be happening. And then, of course, be concerned when you see it happening.
Yeah, absolutely. And I guess as you pointed out, this is something that was patched, I guess, patched back in May 2012. And I think,
Right.
if I understand correctly, and correct me if I'm wrong here, but it was most likely patched in Linux in 2012. Am I interpreting that correctly?
Yeah, actually, it's PHP that has the vulnerability. I think version's 5. So those patches were released last May.
Right. And so the issue might be actually propagation of that patch actually into code that's available in firmware for devices like this, and that
Right.
That ultimately becomes the issue. That is, the embedded device market still has not matured to the point where it has a very, what I would describe as robust patch management process. It may never get into some device designs, particularly, we were just talking about some examples where devices may even be marketed under different names and using code from a different manufacturer. And so this is an area, in my opinion, that needs some improvement generally across the industry. These types of embedded systems are getting into almost anything that you can imagine that's electronic, and even things that are, appliances.
Yes. Yeah, things you don't think of as having a computer in them, beyond a printer and things like that, where I think we all understand that nowadays.
Yep. And we've had a number of discussions around this. We've talked significantly last year about the Karna botnet that was basically, exploiting embedded devices and using that to survey the entire Internet. And we still don't know who's behind that, but there was a lot of data that came out of it. So, yeah, thanks for bringing this one up. This is actually one of those cases where we want to be paying attention and hoping to influence or improve this embedded device industry in general.
Hey, on this topic, Brian, there's another botnet. You mentioned Karna. There's another one we've been kind of looking into. We probably should do a story to cover it. I don't know that we've even touched on it, but it's called the Light Aidra, A-I-D-R-A, I believe, if I remember right. And it's infecting. It's basically a worm type of thing where we'll try to find additional embedded devices, mostly these DVRs, but also home routers, other types of embedded devices, mostly by telnet. It's scanning for open telnet and trying to brute force its way in, or use just, a lot of them don't even have a password set, believe it or not. And then it drops its, it's a MIPS-based piece of malware that drops on there, and then it tries to find additional ones of itself. So it's interesting. These embedded botnets, a lot of times people put them, especially a lot of these devices are at the edge of your network, where you might not have really good monitoring because it's really the very edge of your network, and you're probably monitoring more inside of it. So it's one of those things where you might not even know that you're compromised when this happens. So good thing to keep an eye on your embedded devices and make sure that they're patched and properly protected.
Yep, very good points there, John. Thank you very much. And I guess on that theme, there are also other things we probably should be paying attention to. I know we've been talking about, and we'll, in fact, again, talk a little bit about scanning for PBX management ports. So what kind of, this one actually surprised me quite a bit. What kind of things should we be paying attention to related to PBXs?
So this is another story actually put out by TrustWave. It's a white paper of theirs that I have the link here that you can go reference and read the entire report. It's not very long, but it's interesting. This was a sanctioned pen test that their team had done for a customer or someone. Now, they don't really describe who it is, but it was sanctioned. And what they, during their initial reconnaissance phase, they identified a VoIP PBX, and it was actually an Asterisk server. We've talked a lot about Asterisk. It's open source VoIP PBX software that you can use for your VoIP infrastructure and handling your voicemail and other things like that. So when they identified this system, one of the first things they did is they said, well, okay, let's take a look at it. The web interface was open to the Internet, and they started poking at that, and it had very weak administrative credentials. So they were able to get the admin password to log in to the free PBX user interface right away, which gave them, administrative access to kind of look around at how the PBX is provisioned. The next thing they did is they did a little exploring, and they discovered one of the interesting features of FreePBX is that it has a built-in password auditing feature, so that you as the administrator can see, are any of my users using really easy-to-guess passwords for their extensions? And they determined that, 33 of them were, and, in fact, they were actually just the same thing as their extension number was their password, which a lot of people do. If you do that, you shouldn't do that, because it makes it very easy to brute force your way into someone's extension and use it for fraud. Anyway, one of the extensions they were able to determine was receiving constant call activity, which interested them as well. So they were able to ferret out a lot of this information by looking at the administrative interface that was poorly protected to begin with. Once they did that, they were able to put a backdoor web shell up on the machine so that they could kind of rummage around and look at all the files on the PBX server, which is Linux-based. And in doing so, they found one of the config files for the FreePBX software had an admin password in the clear in the config file. And they said, well, gee, that's interesting. I wonder if they happen to reuse that password anywhere. And in fact, this particular person did, so they're able to SSH right into the machine as root with that password. Lastly, with that access, they were able to actually access the digital audio recordings for these extensions that were there, which you can't do natively through the admin interface, but now that they had root onto the machine, they were able to. In doing so, they determined that this particular extension that was receiving a high call volume was receiving calls for an automated voice response type system that was handling credit card customers that were in arrears on their account. So one of the things the customer would do is when they log in, the voicemail says, please enter your credit card number so we can identify your account. So they do, and they had complete recordings of all of these. They wrote another program that basically decoded the DTMF codes in the audio, and they were able to get all these credit card numbers. So long set of things going wrong in the way they had this thing set up and configured and not really protected led to the fact that they were able to get a lot of credit card information for the customers of this particular person running this PBX. Mm-hmm. So a couple of observations, things that they should have done better that I just noted. First of all, the FreePBX administrator interface was open to the internet, which there probably isn't a real need. We always talk about, if you do need to expose something to the internet, try to filter it to only address blocks that need to get to it. So, use some kind of IP tables or whatever, or a firewall to set up rules so that only those address blocks that should be able to get to that administrative interface are able to do so instead of the entire world. They were using weak passwords, so that was a big problem. They were able to get right into the administrative interface. They're also reusing their passwords, so the same password they used for the FreePBX administrative interface, they used as their root password on this VoIP Asterisk server. And lastly, they had SSH open to the internet as well, which there probably isn't any real reason that needs to be open to the internet as well. So that's another case of where you'd want to filter access to it. There's one other thing that I just thought of when I was looking here, and I forgot what it was, another item, but I guess I'll skip it. But obviously there was lots of steps here that they had done wrong, and they should probably go back. Obviously, that was part of the pen test, is to identify these weaknesses in their security posture, and so I would hope that that's been cleared up. But it's a good lesson learned of what you might want to look at in your enterprise and make sure that you don't have similar mistakes occurring on devices that you have exposed to the internet.
I guess I was going to suggest one additional thing here, John. One possibility would be if you have a firewall in front of the device to be able to require authentication through the firewall, which would give you an extra level. In fact, in my personal opinion, anything that's enterprise-facing the internet, if you're expecting to get into the enterprise, a good practice would be use two-factor authentication. It gets past this issue of weak passwords to a significant extent, and it's a general improvement in the security posture along those lines. So,
I mean, it does get tricky in that the nature of this kind of device needs to be exposed somewhat to the internet. And I think that's where, especially with VoIP PBXs, it gets a little dodgy because you have to allow the SIP interface in, but then there's also other interfaces or other ports that need to stay open for RTP and whatnot. So, if I was to approach this, maybe the interface that's actually listening and handling the VoIP type of stuff is a different interface that you would use for the administrative. So, the one, you have multiple interfaces, one that's handling just the admin web server for the free PBX and the SSH that only you or, your administrators can get to. And then all the other VoIP-facing stuff is on a separate interface that's not listening for those particular services.
Yeah, good point. Makes a lot of sense.
Okay.
Are you done?
Yeah.
Okay. So with that, let's go ahead and take a look at the internet weather for the last week or so here. And, of course, no surprises here. We just talked about the voice over IP management. We've been reporting on this topic for the last several weeks now. And the scan probes on port 5038 associated with the asterisk voice over IP management port continues to be at the top of the list in terms of generating alerts. And I should point out that what tends to generate alerts here are spikes in activity. So if there's a continuous activity, it doesn't generate alerts so much. It'll show up in other types of reporting. So, for example, like in the pie chart that I show near the end of this report. So it's the spikiness in this activity that tends to generate lots of alerts. And, in fact, what we're seeing here is that we saw a relatively large spike on November 30th, and we continue to see a number of spikes around that. And consistent with previous reporting periods here, previous programs, we generally are seeing one IP address that's the source of this probing activity, and it seems to be shifting around over time. And over the last week or so, it's been mostly U.S.-based sources. And I guess another observation associated with it is this tends to be servers that are doing the activity. So either somebody is purchasing or compromising server access to be able to facilitate this probing activity, and they do appear to be related over time. Next item here is what shows up in alerting activity is scan probes on port 123 UDP, and this is associated with the network time protocol. I think I reported this last week as well, and this is looking very much like it's associated with reflection attacks, that is, denial of service attacks that are reflecting off of NTP servers that are available on the Internet. And as you can see here from a flow point of view, the top graph here is showing basically the probes or the flows associated with this activity. You can see that there's sort of an increasing trend in terms of the activity that's taking place. Some of this might be reconnaissance activity, looking for NTP servers that are available, and some of this actually sending requests to those servers, soliciting responses. Now, one thing I should point out here is this is a little bit trickier to look at from an analysis point of view because most of the valid NTP traffic uses the same source port as destination port. As you'll see, UDP 123 source port as well as UDP 123 is the destination report in that activity. It looks like most of this reflection attack activity is, or what I believe to be reflection attack activity, is randomizing the source port. So it actually has some different properties associated with it. It doesn't mean that you couldn't be doing a reflection attack and using the same source port as destination port or even fixing the port otherwise, but that seems to be the observation so far. The bottom graph is actually showing the byte traffic associated with source port UDP 123. So this would be more representative. I didn't want to use the word reflective because I would be overusing it, but more representative of the attack traffic that is being generated here. And we're not seeing huge attack activity. In fact, I think, Jim, you were pointing out earlier when we were discussing this, exchanging analysis notes, that the network time protocol is not a strong amplifier. And so it doesn't really necessarily give the attackers a significant benefit in terms of creating a larger attack. But in this particular case, it would at least give the opportunity to have the attack traffic come from a lot of different places, even if they're originating from one. So it is still a concern. These attacks don't appear to be significantly large, but it does show or represent a diversification in the methods that are being used in these denial of service attacks. And so we should be paying attention to this as it develops. And then perhaps what we need to be doing from an industry point of view is looking at alternative ways of doing controls, perhaps throttling mechanisms on NTP servers to help control this sort of activity. Next item here, I just wanted to give a little bit of an update. This was not showing up in alert activity so much, but it is a topic we had been reporting the last couple of weeks here, and this is related to scan sources on port 21320 TCP. And this is a particular port that I didn't have any strong association with an application. We did see that there was a potential association with a proxy that would be a part of a piece of malware that had been reported by some folks. But what we had seen is that a lot of sources that were probing on this port, perhaps looking for some sort of application that was exploitable, and we did see, a few weeks ago, a sort of a increase in the number of sources that were doing that probing, suggesting perhaps that it was a worm that was propagating on the internet. And in our reports or analysis, we identified that, in fact, most of those sources, the predominant sources, were associated with a single service provider, cloud service provider, suggesting perhaps there was some sort of vulnerability or application or something that was being exploited in those servers. We are seeing a couple of other providers, much smaller in terms of numbers, that are showing up in this activity more recently, but it also is showing an encouraging sign that it's on the decrease in terms of the number of sources. Good news on one hand, potentially propagating to other places. On the other hand, this probing activity is relatively low and slow. That is, it has not created a significant number of probes, so it could be a very slow spreading worm that is on the internet. So if it identifies another pocket of vulnerable machines, there's a good possibility that it could pop up and on the radar again. So we'll be keeping our eye on this to see if there's any development along those lines. Last year, I wanted to share what are standard most probed ports, the top 10 most probed ports, and this one is actually kind of interesting in comparison to normal. Normally, port 445 is near the top of the list. Today, port 445 actually shows kind of way down. Actually, it's ranked fourth here in terms of the volume of activity on that port. On the top of the list is actually the port 123 UDP activity that we had talked about earlier. Again, I believe that's associated with reflection attacks. And similarly, we see activity on port 53 UDP next in line, which is we know to be associated with DNS reflection attacks. They provide more amplification, but also there is activity to try to get that better under control. And then next in line here is port 22 TCP, which is SSH, generally associated with password guessing attacks. And as I suggested earlier, my personal preference would be to have two-factor authentication on anything that's facing the internet. Port 445, as we mentioned here, and then port 443 TCP showing up, and port 1433 TCP showing up in the list. Those are associated with SSL or HTTPS and Microsoft SQL database, respectively. And then we continue to see activity associated with the zero-access botnet, specifically the peer-to-peer communications activity on these ports 16,471, 16,464, 16,470, and 16,465 UDP associated with zero-access botnet. So that's our report for today. If you'd like to get in touch with us, you can get in touch with us through email at threattrack@list.att.com. You can find us on Twitter as well. Our handle is @ThreatTraq. ThreatTraq video is available on the AT&T Tech channel. That's att.com/ThreatTraq. It's also available on YouTube, and you can subscribe to an audio-only version on iTunes if you prefer. I'd like to thank you for joining us today. Thank you, John, Jim, and Joe for your contributions. I'm Brian Rexroad, and we'll be back next week with a new episode. And until then, keep your network safe.